Hi there. We talked today in class about measuring segments. This is your homework assignment for this weekend, and it corresponds to the 7.3 section of your textbook. So we're going to do a handful of problems, one from each topic, so that I can do a quick little teach for those who were absent. Number one is we're asked to find the length of each segment, so find the length of PR. To find a length, you look at the two coordinates of the endpoints, right? So P and R. P's coordinate is -5, R's coordinate is 4. And we're going to find the distance between them by subtracting, by finding their difference. Okay? The interesting thing about this is as long as we take the absolute value, it doesn't matter which order you put them in. So we can do -5 minus 4 or 4 minus -5. As long as we've taken the absolute value, we know that our distance is going to be positive, and that's what we need it to be, right? We're measuring a length. Length is not a negative thing, right? I'm 5.5 feet tall. I'm not -5.5 feet tall. Okay, so this absolute value allows us to put it in either order, so we don't have to worry overly much about doing so. Although if you want to make it positive, just do the bigger one first, right? So -5 minus 4, this is absolute value of -9, which is 9. Or 4 minus -5 is absolute value of 9, which is 9. Either way, you'll get a distance of 9, and you can confirm that by looking at your figure. -5 to 4 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, number 4, we're using the number line at the right for exercises 4 to 6. Okay, so GH is 31. HI is 11, and I'm asked for the distance from G to I. Okay, so our addition postulate allows us to say, well, if I have one segment and another segment adjoining it, then I can find their total by adding those two segments. Okay, so if GH is 31 and HI is 11, then what is GI? Well, GI would have to be 42. Or the reverse would work as well, right? If I knew GI was 42 and GH was 31, well, what would HI have to be? It would have to be the number that when added to 31 is 42. Well, 42 minus 31 is 11. 31 plus 11 is 42, right? That relationship. Number 6, I'm just going to set it up. I'm not actually going to solve it. Okay, so we're using the same figure as what we had above. So we have G, H, I. GH, I'm told, is 7y plus 3. HI, I'm told, is 3y minus 5. And GI, I'm told, is 9y plus 7. Okay, well, again, our addition postulate says that if I have one segment adjoining the other, I can add them to equal the total. So that's what I'm going to do. I'm going to take GH, which is 7y plus 3, and I'm going to add it to HI, which is 3y minus 5. And together they're going to give me my total, which is 9y plus 7. Okay, so that's my formula for A and B. Okay, number 7, we are asked to see if the two segments are congruent. Congruent means same, right? Same length. And so when I'm looking at CE, okay, the distance from C to E, C is right here at -9. E is over here at -1, which is the absolute value of -8, which is 8. Right, and I can confirm that C to E is 1, 2, 3, 4, 5, 6, 7, 8. FD, F is out here at 3. D is back here at -6, which is the absolute value of 9, which is 9. 9 and 8 are not the same, so this is not congruent because those two segments are not of equal length. And again, you can confirm this FD is 9 by counting, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, number 10. 10, we are given the figure KL. right? Number 10 is KL is 3x plus 2, and LM is 5x minus 10. And when we look at this, KL is congruent to LM, right? That's what that little symbol means. This means congruent. So KL is 3x plus 2, and LM is 5x minus 10. And if they are congruent, then I know they are the same. So I have 3x plus 2 equals 5x minus 10. Okay, so I'm going to go ahead and solve this. Let's subtract the 3x over. We get 2 equals 2x minus 10. We add the 10 over, and we get 12 equals 2x, and so then x has to equal 6 when I divide the 2. 12 divided by 2 is 6. But that's not my answer, because what I'm asked to find is the value of KL. And KL is 3x plus 2. So what I'm going to do is I'm going to take that x equals 6, and I'm going to stick it into 3x plus 2. 3 times 6 plus 2, which is 18 plus 2, which is 20. Okay, for the numbers 13 and 16, they're very similar to ones that we've already done up above, so I'm not actually going to solve it, but I am going to set up that number line just so you have something to reference, making sure that you've set it up correctly. Okay, we're told on the number line the coordinates D, E, F, G, and H are -9, -2, 0, 3, and 5 respectively. Respectively means in that order. So D goes with -9, E goes with -2, and so on. Okay, so I'm going to start here at -9 because that's my D, -8, -7, -6, -5, -4, -3, -2, which is my E, -1, 0, which is my F, 1, 2, 3, which is my G, 4, 5. So -9, -2, 0, 3, 5, -9, -2, 0, 3, 5. And so that's what we're going to be using for 13 through 16. Okay. On the back, we're looking at number 19. Number 19 says, suppose the coordinate of P is 2. Okay, so I'm going to go ahead and set up the basic number line here for myself. P is going to be 2. PQ has to be 8, and PR has to be 12. What are the possible coordinates of the midpoint of the given segment? A midpoint means the middle, what cuts the segment in half. Okay, so when I build this number line, PQ has to be 8. Well, it doesn't tell me whether that 8 has to be 8 towards the left or towards the right, so I actually need to take that into account, right? My Q could be in either direction. So I'm going to go ahead and count 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. So that's at 10. Or it could have been to the left. 1, 2, 3, 4, 5, 6, 7, 8. Just down here at -6. Okay, and PR has to be 12. Well, again, they don't tell me which direction it is. So PR could be to the right along with Q, or it could go the opposite direction of Q and be to the left. Same with down here. It could be to the left with Q, or it could go to the opposite direction to the right. So I actually need to draw 2 more number lines for myself, right? So I can take into consideration every possibility. 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my first R, I'm going to go ahead and take it. I'm going to send it in the same direction as the Q. 1, 2, 3, 4, 5, 6, 7, 8. It needs to get all the way to 12. So we're at 9, 10, 11, 12. All right, so that's one possible location. Oops, I'm going to put this on the screen. So that's one possible location, 12 towards the right, which is the same direction we chose to go with our Q potentially. Okay, we'll go ahead and go the same direction with this one as well. So we already went 8. So 9, 10, 11, 12. That might be our R. Or the R could go in the opposite direction of Q, right? So if we took Q to the right, R might have gone to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or same down here, Q went to the left, so R might have gone to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so those are all of our possible number lines, and there actually are number lines for numbers 17 and 18 as well. And we're going to be looking at, well, what are the possible coordinates, right, of the midpoint, right? So for QR, which is the distance from Q to R, Q is at 10, R is at 14, which means that's a distance of 4. And so 2 would get me halfway. Well, 2 from 10 is at 12, and 2 from 14 is at 12. So 12 might be a possible midpoint. Okay. Down here with P at 2, Q at -6, and R at -10, what's the midpoint of QR? Well, Q's at -6, R's at -10. That's a distance of 4. And so again, 2 would cut 4 in half. And 2 from -6 is right here at -8, which is also 2 from -10. On our third possibility, R was at -10, Q was at 10. That's a distance of 20. And so halfway would be a distance of 10. Well, a distance of 10 from -10 is right here at 0, which is also 10 from 10. So there's another possible midpoint. And then our last option, we have Q at -6, R at 14, which is again another distance of 20. Okay, halfway then would be at 10, or 10 from -6, I should say. 10 from -6 is at 4. And 10 from 14 is at 4. Right? Definition of midpoint, they should occur at the same location. Okay, and so our other possible midpoint is 4. Okay, last one, we're on number 28 here. Number 28 says if NO equals 17 and NP equals 5x minus 6, find the value of x, then find NP and OP. Okay, so if NO is 17 and NP, which is this total distance here, is 5x minus 6, find the value of x, then find NP and OP. Okay, well if NO is 17, then so must OP be. And segment postulate, addition postulate, says that if I take 17 and 17 and add them together, they should equal 5x minus 6. So we have 5x minus 6 equals 17 plus 17, which is 34. So I'm going to go ahead and add 6 to both sides. I get 5x equals 40, and so x equals 8. Okay, so find the value of x, x equals 8. But then I want to find NP. NP is 5x minus 6, which is 5 times x, x is 8, minus 6, which is 34. And we actually already knew that, right? Congruency, we knew NP should be 34. 17 plus 17 is 34. And OP is 17, because OP is congruent to NO. And so if NO is 17, OP has to be 17. And so those are my answers.